This video is going to cover the topic of combining like terms. Be sure the date and topic are at the top of your page. The essential question for this video will be, what does it mean to combine like terms? When we are combining like terms, what we really are doing is creating equivalent expressions. We've had some experience with equivalent expressions already, but just as a note, equivalent expressions are two or more expressions that might look a little different, but they mean the same thing. So in our tape diagram, right, we might write this as x plus x plus x plus x, right, this expression, or we might write it as 4 times x, or we might write it as 4x. All of these three expressions are equivalent. Let's look at this model, tape diagram model of an expression. We can see that there are a couple ways we could write this one as well. I could just write it standard, x plus 5 plus 2x plus 1. But I also might realize, well, if I have 1x and I have 2 more x's, I have a total of 3 x's. And I have 5 plus another 1. That means I have a total of 6. So these are two ways to write the same expression. And I think this one's a little more simple. Or maybe a better word for that would be more concise. It kind of combines everything into a smaller version. You'll often hear me or other people calling this combining like terms. And remember, terms are those sort of building blocks of equations, inequalities, expressions, things like 2x or 9 or 4y. Those are all terms that get put together to create an equation or an expression or an inequality. When things are like terms, it means they have something in common. Most often that means they have the same variable. Of course, they could also be the terms that don't have any variable at all. That might make them have something in common. That might make them like terms. I'm going to show you how to combine like terms with this expression. There's no model here, but we're just going to look for terms that go together. And I have different colors, and so if you have different colors, now's a good time to grab it, or you might use different symbols. But I'm going to look and see in this red here that these terms, I'm going to mark them in red, are the terms that have the x's, right? Those are in common. And then I see that I have some terms that don't have any variables. So I'm going to put those in the same color. Those are blue. And then I have this lone variable of y. So that one's kind of on its own. I'm going to organize myself here. So I know that there were 4 x's and notice this has that plus sign, so I'm taking it with it. And there were 2 x's. For my y variables, there was just the one, the 5y. And for my no variables, I had 9 and I had 11. Well, if I have 4 x's and 2 x's, that means together I have 6 x's. The 5 y's are just as they are. And then I have the 9 plus the 11, that's a total of 20. So this expression, which was kind of long and convoluted, is really just the same as this much shorter, more concise version. So this is combined with all the like terms. One thing to note is that this comes really handy when we're solving equations and we get something that's all sorts of convoluted. It's nice to be able to combine like terms and sort of make it more concise and clear before we solve. And this can be done even when the operations in the expression or equation aren't all addition. So that's why you might have noticed that before when I was circling the terms, I actually included the addition symbol or the operation that was in front of it. All right, I'm going to use my color coding again, and I see that I have 9g's and 4g's. That's one group. I have 7 x's, and I am subtracting here 5 x's. And then I have 11 with no variable, and then this minus 2 with no variable. So I have my 9g's plus 4g's in one spot. And then I have my 7 x's, and this is a minus 5x right there. And then without any variables, I have 11 and then a minus 2. And that helps me as I get ready to combine. So the 9g's and the 4g's combine to make 13g's. The 7 x's, if I take away 5 x's from 7, 7 minus 5 is 2, I will end up with just 2 x's to add on. And if I have 11 minus 2 in my no variable group, that would be 9. So I'd end up adding 9. So this long expression just becomes 13g plus 2x plus 9. Before we wrap up, let's try this sneaky one. So there's something tricky about this one, and that is this part here. This part needs our attention before we can combine any like terms. And that is that we need to distribute first. And you may remember that this part here means that I have 4 groups of 2x's and 4 groups of 5. So if I have 2x 4 times, that really means this is 8x's. And if I have 4 groups of 5, that really means I'm adding on 20. So I'm going to say adding 20. And that's just this first part, right? So now, of course, I remember that it originally had minus 6 here. So I'm going to go ahead and circle what I have in common. There's only one value with x right there, and there are 2 values that don't have any variables. So when I rewrite it, I know I have 8x's, and then I have 20 minus 6, which leaves me with 14. So this is the same, the equivalent expression to this one, and that one just took a little bit more effort to kind of get to. That one took a little bit of work there. For your turn, we're going to take out that extra tricky element, and I just have kind of a basic expression here. I want you to look it over, use different colors or symbols to identify the like terms, and record an equivalent expression that's more concise. And remember that the essential question was, what does it mean to combine like terms? And so now you've sort of seen a few examples of that and what it is that I mean when I say combine like terms.